Hello, everybody. I am promoting everybody to panelists so that they can interact and we can all see each other. I'll do proper intros and start properly at the top of the hour. Doing this single-handedly today. We normally have a couple of people running these, but I'm juggling a little bit, so do excuse me if I seem a little distracted from time to time. Four minutes to go. It's 9 AM there, isn't it, at the moment? So what is it here? It's 5 PM here at the moment. So I'm at the end of my working day. You're at the beginning of yours. So somehow we'll get onto the same wavelength. I will do introductions and everything in a second. Lots of people in. Judith, I said you're logged in a couple of times. Don't know if you're having problems, but this is going to be recorded as well. So you can use it as reference for any of the things that we go through. God, people are joining quicker than I can click on them to promote to be a panelist. Hope I'm going to get to know a lot of these names as well over the coming year. Anyone want to say hello? You can unmute so we can test some audio so I can see if I can actually hear you. That would be good.
Hello.
Oh, yeah, great. Thank you, Amber. Thank you very much. I was getting worried there. It's never good when you're trying to do one of these on your own. So, loads of people coming in. This is great.
Hello.
Hello, that was a bit echoey. Who was that?
I'm Frank.
Hey, Frank. Nice to hear from you. We are going to start in a couple of minutes officially. So let me just get these last few people in. So tell me, somebody, is this your first session of the day?
Yes, it is.
It is. Okay, so I've got you when you're fresh. Hopefully you're all caffeinated properly, if that is your poison. So you must have, this is going to be a very long day, I guess, for you guys. So I will try and keep it as short as possible this morning for my little bit of it. Just inviting these last few people.
Hello, can you hear me?
I can indeed, Frank. Thank you very much.
Okay, I'm Scott. You just promoted me to a panelist. Is that right?
Say again?
It says you promoted me to a panelist.
That's correct. I'm promoting everybody to a panelist just so that you can interact with audio and visual. It's nice to see everybody's face. And I would ask, actually, if anybody does have any questions, if I'm not going to be able to keep an eye on the Q&A or chat here, but if any of you can, who have got audio, if you could just interrupt me at any point if somebody puts a chat in now. I've just got so many screens open, you wouldn't believe it. How are we doing? We are, I think we're at the top of the hour. We've got 23, we've got 33 people here. So let's kick off because I don't want to keep you long. Good morning, everybody. I am Paul Cox. I am Slooh's, I've got the best job title in the world, Chief Astronomical Officer. I'm also our acting director of education at the moment, and I'm so pleased. We've been working with Dr. Malin over the last 8 months to get this set up for you. And some of you might not know that much about what it is you're about to get into, but we're really hopeful that we've got something that's going to engage your students who might not normally be into science and STEM and all that kind of stuff. But hopefully you can all see my screen. Can you see my screens, everybody? Just give us a thumbs up if you can. Yep, great. Thank you very much. Well, I'm going to give you a very brief introduction to Slooh, and I will make this apology that I'm doing this single-handed today, so it might be a bit clumsy because I've got your screens over screens that I'm trying to share and stuff like this. But what I wanted to share with you from the outset is we're going to go into all of this. I'll introduce Slooh and everything else. But these are examples of what your students are going to generate when they use Slooh's online telescope platform. All right. These are what we call our infographic posters, and they're one of the outputs from our learning activities, which are called quests. And I'll just skip through a few of these. This is our Solar System Explorer. That's a special one that a lot of students absolutely love. This was a special quest that we did for a Halloween Blue Hunter's moon. And all of the celestial images, so the images that you're seeing of stars, the moon, planets, and everything else. So here we've got another one of nebulae and star clusters and stuff like this. All of those images are taken by your students using the telescopes at Slooh, and the images that they capture are automatically inserted into their poster, their personalized poster. This is another one where students are learning about the 4 different types of nebulae. So once again, these are all images that were captured by the student, which automatically get inserted into these posters. Now, I just want to tell you one thing while we're looking at this one. Those are snaps from a live telescope view. That is exactly how these objects looked in the live telescope views. This is of the sun. This is tracking solar features across the sun. This is one of my favorite objects of all time. It's the Great Orion Nebula, which is just coming into view, and we've got a whole quest just about that. This is a huge collection quest. So if you've got, I know a lot of you are going to find, because we've seen this in every other school and institution we've gone into, you're going to find that a few students absolutely run away with their use of Slooh and far outpace the pace that you're walking through all of the quests. So what we've got is we've got a few quests like this, where students can capture objects in these collection quests. This is 110 objects in the Messier collection. They learn about Charles Messier, why he was cataloguing these particular objects, but actually they're 110 of the most beautiful and stunning objects in the night sky. And your students will produce things like that. They'll also learn, hopefully, about lunar cycles and lunar phases and capture through the live telescope views over the course of a month these live images of celestial objects. Now, Slooh, what are we? I'm not going to labor too much about this, because you can go onto the website. So if you just go to www.slooh.com, this is a page that you land on. Can I just have a quick thumbs up whether or not you all received your credentials yesterday, your Slooh credentials for accounts? So you should have had an email over the last 24 hours. Yes, some people have, others haven't. We can tackle that afterwards. Maybe you haven't checked, because I know a lot of them were just going out last night. So hold on one sec. I'm just going to promote some more people to panelists so that we can see everybody here. So Slooh started off in 2003. We actually launched on Christmas Day, would you believe? Suckers for punishment we are. And we launched our first observatory in the Canary Islands. And what we've done over the last few years, we've honed the service into being a platform which is really, really focused on education. We're absolutely passionate about astronomy being a marvelous gateway into other STEM subjects, because it's engaging. Anybody can do it. Anybody can be an astronomer. Amateur astronomers are still making discoveries every single day, every single night. So what we've got is a bunch of online telescopes based at 2 observatories, one in Chile, one at the Institute of Astrophysics of the Canary Islands, which is actually where the largest optical telescope in the world is based, and our telescopes are just a stone's throw away from those. Some of these telescopes that your students are going to have access to and going to be able to control and capture all of these images. Some of your students could actually fit inside them. They are so big. Let me show you. I don't know if you can see this. I don't know if you've ever seen anything like this before, but it's pretty peculiar. This is actually an astronomical CCD camera. This is cooled down to minus 40 degrees C, right? And this is on the back of these humongous telescopes. Our biggest telescope is a 1/2 meter telescope. And when we talk about the size of a telescope, we're talking about the size of their primary optics, which is in that case a mirror. And that's what they're using and controlling. Now, if one of your students fancied owning one of those, they've got to invest about $100,000 for each telescope. And your kids are going to have access to loads of these every single night, both in the Canary Islands and in Chile. Now, so there's a really kind of stunted summary of what Slooh is. And what you've been given access to is our top tier education account. So this is a teacher account for you, and each one of you have got 30 student licenses where you can invite your students to use the platform. Everything I'm going to show you over the next 20 minutes, your students are going to be able to do. But I just want to cover a couple of really simple bits of admin. Now, this is being recorded, and I'll send the recording link to Dr. Malin, and she can share this so you can watch this. But we've also got lots of other webinars as well that you can watch. And I've got one in particular that you can point your students to that shows them how to use the platform. But I just wanted to show you one thing really quickly, which was a bit of housekeeping. Now, I am logged in here. We're going to start right at the beginning in a second, but this is one of the most important things for you guys at the moment, and it's how to invite your students to the platform. And what I always recommend for any new teacher, when you're getting to know the platform, invite maybe 3 or 4 students that you've got an inkling might really take to this kind of thing. Get them learning the platform alongside you, because what other educators have found is if you've got your own little support team of expert students in your class, they can start helping out and helping out the other students. But anyway, this is just the logged in view. And I'm going to go straight to one place. So excuse me, I'm going to dive into a couple of places. This is how you're going to invite your students. You click this little profile icon up here, and you go down to My Workspaces. You click that, and here you can see create a new workspace. Now, a workspace is a private area. It's like a forum for just you and your students to use. So you can create your workspace. You can call it. I've run out of ideas. I'm using the wrong keyboard as well. I'm running out of ideas, so you'll have to excuse me. We're going for test 1. Right? You can put a little message in here that your students will see when they do this. So you're going to create a new workspace. Oh, I've got to enter a message. So hello. Create a new workspace, and there it is. It's taken me straight to it. And then we're on the members tab here, and you can see a little invite button here. Can you all see this screen okay? Yeah, not too small or anything like that. So yeah, got thumbs up. All right, press the invite button. And what you can add in here now is, let's go for, I haven't done a Charles Cox yet. Charles Cox. charles@slooh.com, and you have to confirm that email address. This is your student's first name, last name, and their email address, and you just click send invitation. Charles is about to, when my machine kicks into action, has just received an invitation email, which they click a link in it. It brings them straight to Slooh. They enter their password, whatever they want, and you'll see when they've accepted it, the status here, that they're active. All right, so you can see when your kids have come in. Now, some of you, if you don't really want to do that for all 30 kids, there is another way that you can do this, but I'm going to say to you, use it with caution, right? And it's this thing here, view workspace sign up link. Now you press that and it comes up with this absolutely unique link up here. Now, if you share that link with your students, they follow that, they put their own name in, their own email address in, and they land up in your workspace. But here's a proviso. Don't let them share that anywhere else, because anybody with that link will be able to follow that process, right? So but it is a very easy way if you've got a whole stack of students that you want to bring in. So that's it. That is as simple as it gets to invite your students in. You can, and I'm not going to go over this today because we've covered it in a number of other webinars, which I'll give you the links to. You'll see here, we've got quests completed and quests in progress. So don't forget, if you're late joining, quests are our learning activities, and all of our learning activities, our quests, you saw the posters to them, involve the use of the live telescopes. Now, when your students have come in and they've started some of this work, you can press on this little view details button here and you can see their progress. You can see, I'll show you in a sec, quests are split down into different steps, and you can see how many steps they've progressed. You can download a report, a PDF report that shows you exactly what the answer to their questions are, the images that they've captured and stuff like that. But I want to jump out of that because that basically is the only admin that you lot have got to do, right? The rest of it is all about using the platform. So I'm now going to log in to my normal account because it's just got more examples of the stuff. I would urge you to take a look at this page if you haven't done already. And I'm not going to cover all of that stuff, but it'll just tell you about the standards that we cover, NGSS alignment, and how we're aligned to the curriculum. But this is where you'll come. So you'll go to www.slooh.com. This is where your students will go to. Click the login button up here, the login link, and you enter your sign-in details and sign in with email. That's what I'm choosing to do. And where you land is on our dashboard. This is what we call the Slooh dashboard. Now, don't be put off because there's an awful lot of information on here, and I've got more stuff on here, I have to say, than most people. And what you'll see takes pride of place is what we call our featured quest map. So these are our learning activities, and they're split down into different zones. We've got an observation zone, a learning zone, a heritage zone, because we're not just about science at Slooh. Astronomy has this wonderful ability to be able to stretch out into not only the science and the math, but also mythology, culture, art and literature. And when you see some of the images that some of the students produce and some of the poetry that they've written around the images. But anyway, quests are designed to do all of that. And you can see down here, we've got 3 starter quests. And I always recommend to everybody, to all of you, to start with Nifty Nebula. Now, some of this is going to change next week because we've got a new update for the new year. And I've only just finished actually a new starter quest today where your students will capture either the sun or the moon and just learn about the solar system, and then they can learn about the Milky Way domain, which is nebulae and star clusters and stuff like that, and then they go into deep space and look at galaxies. But I just want to show you very quickly here the Nifty Nebula quest, because all quests are structured in exactly the same way. Now, this is one that I've actually completed. We view the quest, and this is all going to be zhuzhed up as well. We've got some great developments coming up in Quest. But for all of you, one of the interesting things here will be how it's aligned to curriculum and course standards and stuff like that. Now, if some of you are not science teachers, and I know some of you aren't probably, one thing that we align our quest to is something called the OpenStax textbook, which is an open source. Anybody can download it. So you can download the OpenStax Astronomy book. And you can see here, we're saying that this particular quest is aligned to 2 chapters in that book. And I'll tell you, a lot of our even really, really experienced science educators use OpenStax. It's a great framework to use in teaching astronomy. But anyway, there's just some basic information here. It tells you when you can do it. It says how long it can take. It's got the level. It's got something here called 100 gravity points. Well, gravity points is all about the gamification of our platform. And I was a bit suspicious of this, I have to say, because I'm not a gamer. I'm a bit of a geek, but I'm not a gamer. So gamification to me kind of put me off, and some other members as well. But you wouldn't believe how much everybody's got into this. Every single thing that your students do on Slooh will earn them gravity points. And it's really about their contribution to the community and all of the activity that they're doing. And what we've had fairly recently, just this year, is some educators, a couple of universities and 1 college, have been using gravity points actually as the target of assessment. So one of the universities just said to their students, you have to do this quest, and this quest, and you have to earn a total of 3,000 gravity points. And that was how they assessed the work that they wanted their students to do, which was a really, really good idea. And actually every webinar I've held since, other people have agreed with that. But anyway, let's skip down here, because I do want to show you a lovely live view in a sec. All quests are split down into different steps, and I'm not going to go into a great deal of this, but we've got introductions which are really about the teaching content of it. But this particular one is showing us 4 different types of nebulae, and your students learn about that in the quest. So this is a step, and so I have finished this, but this is giving a lot of information about what is an emission nebulae, why does it glow. So nebulae are basically clouds of dust and gas. We've got some objects in here, some targets that we suggest your students use. But so they learn all of that in this little module here, this panel. This is where they capture their image. Now, normally, if they haven't captured any images of a particular object before, they'll see a button there that says Find Image, and it'll open up a page of their photos. I'll show you that later. Or if they haven't got an image of the particular object or object type that the quest requires, it takes them directly to a page where they can schedule what we call a mission. And a mission is basically a 5-minute period where one of your students is controlling the telescope to point to a specific object and capture images. Right, so they're taken straight to that. So this is, I told you we started in 2003. We have honed this down with so much feedback from everybody. But the end of each step, so this one, so this is the image that I captured. So they see it slightly bigger, and they're asked a question about it. So we got multi-choice question, we got free-form question and answer. So here we're asking them to describe and analyze exactly what they're seeing in the image that they've captured. And then they finish that particular step and they continue to the next step. All quests culminate in one of 2 things. One of those glorious posters that I showed you right at the beginning, but some of the quests, like the one of the quests that I wrote is about in the footsteps of Clyde Tombaugh. Clyde Tombaugh's the guy who discovered the planet Pluto, which is now unfortunately being demoted to a dwarf planet. But he discovered that. And what your students do is learn about what Clyde Tombaugh did back in the early 20th century. And they replicate exactly what he did, although he was using huge glass plates to take his photos of several hours, whereas your students are using robotic online telescopes. But they use exactly the same technique to take an image of where they think Pluto is one night, they take another image the next night, and then we have this lovely tool where your students align the images with all of the stars, and then they turn it into an animated GIF. They animate it and they flip between the images. All of the fixed stars stay exactly where they are. But what they're looking for is the tiny white dot of Pluto moving against the background stars. So anyway, that's the other kind of output from a quest. But I'll just scroll down here. And this shows you the finished quest poster. Now, a lot of the quests as well, I told you they have free-form questions, so they might be adding an observation. That text also appears on their poster. So that's quite a cool thing as well. These posters, by the way, a lot of schools are getting these printed out. They're designed to be printed off at a local print shop. They're incredibly high resolution. There's something like 7,000 pixels high and 4,000 wide. They print off in beautiful, beautiful quality. And they've got these posters down the walls outside the science classes. But anyway, you can download these and stuff like that. That is the structure of a quest. I'm not going to go any more into quests because we've got other webinars that deal with this that you can watch. And also we're doing one with Slooh's Director of Education next week on August 10th, if anybody wants to join us. And I'll show you where you can find those. In fact, I'll show you now where to find all of our star parties and webinars. You hit this little, the 3 lines we call the hamburger menu up here. You click that and you go down to what are called star parties. And you can sort these by professional development. And here you can see, say yes? Someone got a question? No, okay, carry on. So you can go back and you can view all of our previous webinars. Now you'll see here, we've got one that's teaching high school, one that's teaching elementary. These are teachers who are hosting our professional development webinars and showing other educators how they use this platform within their classroom, and they are really, really useful, I have to say. But anyway, you can, if you go to the all-star parties, you can flick through here and you can see the upcoming ones. So I'm doing one next week that your students could join, which is just an intro to how to use the platform. And then that's a member one. And then we got using Slooh in higher education, if anybody's interested in coming to that. And you just click on that and it gives you a registration page and stuff like that. But I wanted to show you, please, because I always get people who watch my webinars and my star parties always know that I'm like a dog who's spotted a squirrel, all right? Because I'm trying to tell everybody something and then I spot a live view. And we've got one live view at the moment. These are all of the telescopes, and you can see Chile 1 and Chile 2 and Chile 3, they're offline, and that's because it's daytime over there. Canary 1, Canary 2, Canary 3, Canary 4 are offline because it's daylight there as well. But look at this, the Canary 5 telescope says it's online, and that's because it's an incredibly special telescope. This is a live view. Hopefully you can see this. I suspect the quality is rather degraded, all right, in the screen share and stuff like that. This is a live view of our sun through what's called an H-alpha telescope. So it filters out basically 99.9% of the sunlight that comes in, which allows us to see all of these surface details. You probably can't see it, but I can see a prominence coming off here, off the edge of the sun. We've got a large filament here. This is superheated plasma reaching off, being sculpted by the sun's magnetic fields, which are bursting out of the surface. We've got a huge active region with some sunspots over here. And although this is video, the nighttime telescopes are more of a static image feed that produces static images, but it's the same kind of view. And your students can come into any of those telescopes when they're operating and press this little button here, the little camera button, and you'll see that a little thumbnail's appeared up here. I have just snapped an image from that live telescope feed, and that's what they can do at night. So they can control the telescope themselves to point to whichever object they want, but they can watch everybody else's, don't forget I called those things missions, those 5-minute periods where the telescope's pointing to a particular target for a particular person. But everybody can view everybody else's missions. We kind of call it a celestial jukebox. So telescope rental systems and some of those that have been used in education, only one user can use the telescope at a time. Nobody else sees what they're doing. So this is all about community and a communal exploration of space. But that kind of gives you a pretty good idea of what your students are going to see. And then at night, when these are online, you just click between them. And we can actually, there's some other stuff over here. We can click this. This is an all sky camera view of the Canary Islands. So these are the two white domes holding the telescopes in there. This thing over here that's gone really spiky is the sun. We can see we've got a few. So that's what we're looking at the moment, which is pretty cool. And at night, in that same view, in fact, I can show you. I'll open the time lapse here. In fact, I'll go to one of the other telescopes. It'll be easier for me to show you in one of the other telescopes. So I can open the time lapse view here, and hopefully you can see this. This is what your students see at night. Now, this is a time lapse, but you can see there the Milky Way is going through that really bright object there. That's Jupiter just rising, followed by Saturn and Mars as well. They look absolutely glorious at the moment. You can see we've got no moonlight around at the moment. So this is from last night. And the Canary Islands Observatory is located at the Institute of Astrophysics of the Canary Islands. So it's basically on top of an 8,000-foot volcano in the middle of the Atlantic Ocean. Actually, it's 300 miles off the west coast of Africa. There you can see the sun panning up through there as well. Let me just clear that. Close that down. So anyway, it's the skies there are just absolutely sublime. They're protected. Their skies are protected by law against light pollution. And that's one of the biggest hurdles that I live here in the UK. One of my biggest hurdles is clouds, but we've also got loads of light pollution. But a lot of kids, especially from urban areas, are so disconnected with what I just showed you there, the Milky Way. Most kids probably haven't even seen the Milky Way. They probably haven't seen anything but the brightest stars and planets because of light pollution. But this gives them direct access to that on this live platform. Now, I don't know if you remember, I'm going to show you in a second how your students control the telescopes. I'm going to invite a few people back into to panelists. If anybody wants to just join as a panelist, you can then have your video on and stuff like that. Got lots more people. Don't forget, if you were late in joining, doesn't matter. I know it's early in the morning for you guys over there. It's 5 o'clock in the afternoon for me here in the UK. But you'll be able to watch this live recording anyway. So I've just invited a few more people. Right. I'm going to show you how your students can control the telescopes in a minute to gather their data for their learning activities, the quests. But I just want to take you very quickly over the dashboard. So there you can see the quest map, which I told you about. There's way more quests, by the way, than that. These are just the featured quests, and you can find all of them up here by going to My Quests. I won't show you that for now. But on this right-hand panel, this is all about the gamification. So you can see here, these are my gravity points. I'm a Hubble level member. There are 9 levels, depending on how many gravity points you get, all named after famous astronomers. We've got the badges that I've earned. We've got the recent activities that I've done, which have earned me gravity points. My most popular objects. Then we've got league tables down here as well. So this is all about gravity points. And what you can do is you can, in your classes, when you invite your students in, you can be as ring-fenced and private as you like, but you can also choose to have your class on the Slooh community leaderboards. So they'll show up in here, both individual students, the most gravity earning of all time and stuff like that, but also your class will appear in here as well. So that is all about the community and gravity points on the right-hand side. The left-hand side is all about your personal activity. So there are your quests. Here's a couple of panels which are talking about when the observatories are open. Now, I do know that this is a huge amount, right, that I'm cramming in here, but I want to cram it because you can rewatch it, catch up. But if you know that these things exist, you might not remember them, but you'll remember that they exist and be able to come back to it. So these are my missions at the moment. And actually the easiest way for any of you or your students to schedule a mission is using this particular feature here, which is featured missions. And you can see here, every week I set 3 featured objects, the best objects to look at that particular week in my particular personal opinion. And we've got a great comet to look at the moment, Comet C 2017 K2 Pan-STARRS. We've got two of my favorite galaxies, the Triangulum Galaxy and the Andromeda Galaxy. And let's say you want to schedule a mission, control the telescope, to grab some data and images of that comet. This is using the Canary 1 telescope. All I have to do is select Join Mission. I confirm it. Look, it's telling me the telescope. It's telling me it's going to be tonight at 2100 UTC. It's telling me the weather forecast is clear. So yes, we'll definitely join that mission. Thank you very much. We can come here and we've got an object guide page. So all of the objects that your students can capture have got a guide page, which has got the history of the object, who discovered it, all the scientific data about it and stuff like that. But that's it. You can see here, I have now joined that mission with a whole bunch of other people. Right? I'm going to show you how better ways, I think, of setting up missions. But I've got way more missions in here than most people would have. But I wanted to show you this. This is our object map. Now we have something called the Slooh 1000. The Slooh 1000 is like this catalog of the best and most interesting objects in the night sky that look great through the Slooh telescopes. And this is basically a map of the entire night sky. And when you're zoomed in this far, you know, you can see their names and stuff like that. But I'm going to zoom out because I told you we've got two observatories, one in Chile in the southern hemisphere and one in the northern hemisphere in the Canary Islands. And this is a map of the entire sky from north to south, from east to west. You can see here we've got the sun, and this gray area around the sun is where the nighttime telescopes can't point to because it's not nighttime. So we can't capture those images in there, in that area. But you can see we've got virtually the entire sky is visible every single night using both telescopes. Now, the objects down here, far down in the south, they're not visible from the Canary Islands. You can only use the Chile telescopes for that. But there's actually quite a few learning points just within this map that you can get your students looking at. I love spotting patterns, and most of us who love a bit of science, you know, like to spot patterns. Now, we can filter this object map by object type, and I'm going to filter it by nebulae. So I just want to see where are the nebulae, and suddenly you see that pattern that you may have spotted before suddenly become really quite prominent. And it's here, it's this pattern here. It comes up over the top in this huge S-shaped or snake-shaped pattern. And that's showing us, that's actually how the Milky Way appears on a map like this. So we're in our Milky Way, we see it edge on, and that's showing us that the distribution of nebulae in our galaxy, the Milky Way, is predominantly within the plane of the Milky Way. Now, if we filtered on other objects, like let's go to star clusters, maybe. Star clusters are, where are they gone? Globular clusters. They tend to orbit the Milky Way, both north and south, and you can see the distribution is totally different. So there's some nice learning points there. So I don't normally show people that, but I get excited about small things like that. Now, this is an important area for your students. This is my photo roll. Now, you'll remember I snapped a photo a minute ago, and this is it here. This is the photo that I snapped. I can write my own, what we call observation, and we really try and encourage students to do this, to write their own observations and share it with the rest of the class, or even the rest of the community. Now, you can choose whether or not you want your students to share them with the rest of the community or not, but it earns them gravity points and stuff like that. But anyway, we'll go back because I do want to show you some of the views that we have seen, actually just some of the other views. I'll show you some of my favorite objects. So what have we got here? We've got Saturn there. I just want to skip through here a bit. So this is last night's, and then the night before. They take a while to turn up. So actually, I did join a huge number of missions. So I'm going to sort this on solar system, which is the quest I've been working on today. And we'll take a look some of hopefully what we saw yesterday or the day before. So this is just sorting all of my images of the solar system that we saw. Oh, I've got to go back a bit further, I think. Oh, there's that comet that I was telling you about, Jupiter again. I'm trying to find one of the really cool images. I'll tell you what, there's a better way of doing this. So those are all of my images that I've captured. But what we've got, I just mentioned observations for your students. I'm going to wind up in about 5 minutes time and take some questions and then let you all go. This is where observations go. So these are images that, that members and students have taken and share as an observation. We always try and ask students, especially, not to just copy Wikipedia entries over. You know, this is about, an observation is about why that particular image is important to them. And it could be as simple that it's the first image I've ever taken using Slooh's telescopes of the planet Jupiter. It might be some poetry that a particular image of a nebulae has inspired them to write. But anyway, these are the featured ones, and you can click through and have a look at these. Oh, so this is the view. This is a pretty good view. This is what we were looking at yesterday. All right. This was the sun yesterday through the Slooh Canary 5 telescope. Look at this huge prominence over here. Now, we estimate, in fact, the size of this sunspot here, hopefully you can see the one that I'm pointing to, that is about the size of the Earth. So you can see about 20 Earths would have filled this entire prominence. And this prominence is superheated plasma being sculpted by those magnetic lines. But what happened yesterday, shortly after we witnessed this, is the magnetic lines sometimes break. And when they break, it's no longer confining and sculpting that plasma in that huge prominence. And what happens is it then releases all of that plasma into space. And what we've seen over the last couple of weeks, while we've been watching the live views from the solar telescope, is on the surface here, these huge flashes, they don't happen instantaneously, it happens over a period of minutes. And that's the release of huge amounts of plasma that then come hurtling, high energy particles hurtling towards the Earth. And you may have read a couple of weeks ago, a couple of those flares, they affected some satellites, and they affect satellites in two ways. Most satellites are shielded from those high energy particles, but it can cause problem with the electronics. But also, when we get a flare, this burst of energy from the sun like that, it can heat the outer atmosphere enough to expand it slightly. And the low Earth orbit satellites then encounter more drag. And this drives NASA and other, your cable TV people up the wall, because they have to burn fuel in their satellite to boost the orbit of their satellites. So they hate that. But anyway, I just thought I'd show you that because that was what we were looking at yesterday. But so these are all views, and this is a great place actually for you guys to start to see what other people are doing using the Slooh telescope. So some of these are processed. So they've taken the data, the student has taken the data and processed their own image. Other ones are live snaps directly. So that is a live snap directly from the live telescope feed. And we can go to the all one and we can see the same kind of thing here. So I'm going to show you one thing. Oh, that's a lovely, lovely galaxy there. And that deserves a like. That looks like, yeah, it's the Pinwheel Galaxy, a beautiful galaxy, M101, part of the Messier catalogue. So I've just liked that. That member has just earned gravity points because I've just liked their content, because they've made a contribution to the community. But I want to show you the other ways that your students can control the telescopes. And they come up to this dome icon. And I'm going to point you to, I'll share with Dr. Malin a couple of previous webinars that go into all of this in way more depth. But anyway, the way to do it is go to Mission Setup, click that button. And I told you, we've got that list of the Slooh 1000 objects. That's what your students have got access to. To control a telescope, it needs 3 steps. Now, first of all, I'd like somebody to give me what kind of objects. So we've got solar system objects, we've got planets, we've got star clusters, we've got nebulae, we've got galaxies, stars. Has anybody got a particular object type that they want to sort by? Just shout it out. Come on, teachers, come on, wake up. Wake up, all of you. You obviously haven't had enough coffee, or you're struggling to find the button to unmute yourselves.
We want to sort by nebulas.
Nebula. Okay, so we've got 4 different types of nebulae. I would recommend emission nebulae at this time of year because there's some absolutely cracking emission nebulae at this time of year. So I'm going to select that. That's step 1. Now you can see this funny whirring thing. This is not just a Slooh website. This is what we call the Slooh recommendation engine. And it's going over the Slooh 1000 catalogue of objects, and it's hunting for all of the emission nebulae which are visible at either observatory over the next 7 nights. And it's then produced a list over here. Step 2 is choose the object. Now, the ones that are shown in bold are visible. Let's see if we can find any grey ones. I told you most of the sky is visible at the moment. Look, there's a couple here that aren't visible because they're too close to the sun, or maybe they're too close to the moon as well. But here's a good one that students love all the time. In fact, there's a couple here. There's Thor's helmet. So if you're a Marvel fan, this beautiful, beautiful nebula looks like Thor's helmet with 2 enormous horns coming off it. But another favorite one is the Tarantula Nebula. It's a southern hemisphere object, so it's only visible from sky, but that's what they do. They click that. So if they were doing the nifty nebulae quest, the Tarantula Nebula is one of the recommended nebula to use for that because it looks absolutely astonishing in the live views. All I have to do now is preview the mission. And Slooh has gone through the best telescope to use, the best time to do it. So this one is scheduled, it's for tonight. It says Saturday, August the 5th, but the time of that is actually 0505 UTC. And that you'll see there's a schedule, which has actually got PDT and EDT on it as well. But it's basically said, that's the target that you've chosen. That's the time the mission is going to run. It's going to run on the Chile 1 telescope, schedule the mission. That's the end of your last step. There it is. I have now told the telescope at that time, that particular telescope to point to that particular target. Now, I get a reminder 15 minutes beforehand that that mission is going to run. So I can jump onto the platform. I can open up the live telescope views and I can press that little camera button. But your students won't necessarily want to do that at midnight your time. So all of the images and all of the data from this particular mission are automatically saved for them. So when they come into school the next day, they come into the dashboard, they scroll down to their photos, and all of their photos from that particular mission will be in here ready and waiting for them. Right, but don't forget, they can also watch the live views of everybody else. Now, I'm going to show you one more thing, and then I'll go over to questions. That way of scheduling the telescope, the student had virtually no control over it whatsoever. Slooh did all the work, when, where, which telescope. So I want to show you another way, and this is the biggest thing that I'm going to point out to your students if they come to a webinar next week, or try and remember this method. If you can. So I'm going to click this little magnifying button. I'm going to click on, I told you at the beginning, I need to use the right keyboard. If I can type properly, it's near the end of the day here, please excuse me. I just typed Orion and press find, and it shows me all of the objects and guides that we've got related to Orion. But this is the one I wanted, the Orion Nebula. It's just coming back into view early in the morning. This is the guide page that we have for all Slooh 1000 objects. It tells us a bit about the object. It tells us what type of object. It tells us the domain it's in. It tells us the constellation it's in. Here we've got the most recent observation. So this was taken by somebody 2 days ago, 3 days ago, right? This is a snap. This is what the Orion Nebula looked like in a live telescope view, right? But further down the page, we've got about the Orion Nebula, lots of information. This shows its visibility over the entire year. So there's some great graphing stuff in here that you can do with your students. So x-axis is showing the calendar year. The y-axis is showing the altitude in the sky. The dotted blue lines are showing the moon when the moon's up, because really, if you're capturing faint objects, you don't really want the moon to be up, but you can see this is the best period. But we don't really want to come to this page. The page I want you to point your students to. By the way, you can go to Illuminations. Illuminations, a whole stack of really interesting articles, mythology, storytelling, art, literature related to this particular object. You've got Ask an Astronomer, where they can type a question in here and I'll answer that in the morning. We've got star parties related to this. We've got observations related just to this object, but this is the tab I want you to take your students to. Missions. And suddenly we can see on this page that it's giving us, so this is the visibility, this is a nightly visibility now, and it's offering me a mission here, and it's offering me probably a few missions down here. So suddenly it's offering us Chile 1, it's offering us Chile 2, and different times. I don't know if you noticed, but at the top of the page, we can select a day. So your students can come in here, select a day. Let's say they know that they can watch live at the weekend, which is what, August 7th. There we go. So they click on August 7th. Now this page is offering us missions on that particular date and different telescopes and different times. Right, so I'm going to go for, you wouldn't actually choose this one because it's light clouds and partly cloudy skies are forecast, but I'm going to press schedule mission and schedule. You can see there that immediately your student has far more control, granular control over when the target is going to be captured and also the telescope that it's used. I think I have probably exhausted my time. I would love to get to some questions. Now, I know this has been an absolute baptism of fire and throwing you in at the deep end, you know, on what kind of can be quite a complex looking platform. But if you get a couple of your avid students in here working alongside you to learn the platform, right, they'll do a lot of the hand holding of other students for you. It's really, really good to have just that small body of experts in using this. And you'll soon find that other students get rather competitive as far as the gravity points are concerned. But has anybody got any questions? I will, don't forget, I'll send Dr. Malin the recording of this webinar, but also a couple of other webinars as well, which you should have received, I think, in the welcome email with your credentials. But anybody got any questions for me?
I have a question.
Yes. Hi, Jenny.
Hello, how are you?
I'm very well, thank you.
Okay, since the telescopes are used for many different purposes, is there also a way where the students can see, I guess it's called the transit method, to actually be able to track the moment in time where a planet comes in front of its star and ever so slightly there's a dip in light, to have an idea of learning more about the planets through that?
Okay, not the planets necessarily, but on any of our guide pages. So there's a couple of different things going on there. Let me just do, if I use the right keyboard once again. M31 is the Andromeda Galaxy, and I go here. There's something called the midnight culmination of an object, all right? And that is shown here, and it happens right there when the object is at its highest, midway through the night. That's the midnight culmination of the object, and that's also called the transit as well. If we look on this object for the missions and the graphs there, we can see that we've also got a graph, and this is showing a student, basically, you want to capture that object closest to its peak as possible, because that's when it's highest in the sky, when we're looking through less atmosphere. But from the other thing that you were talking about, Jenny, we have seen transits, and we see nightly transits with Jupiter, where we see the 4 Galilean moons cross in front and behind the planet. And we also see what are called shadow transits, which are the shadow of the moon crossing. We also see the planets at opposition. Saturn, by the way, at the moment, let me just show you Saturn, because Saturn is a really interesting one as far as the seasonality of things is concerned. It does help if you can spell this. Could somebody mute their microphone? Anybody can do that?
I believe that's Scott Cairns. Scott, please mute your microphone.
Thank you, Dave. So here's the latest image of Saturn that was taken. Now, if you compare this to an image, and your students can do this, they can go into the observations, see images that students captured last year, and they will see that last year it was actually summer, the equivalent of summer in Saturn, because Saturn was tilted really quite a long way towards us. We could even see the gap in the rings behind the planet. Now what we're seeing is Saturn over the next couple of years is going to reach equinox. So the rings will totally disappear. But one last point there, Jenny, we do also see occultations. So we have been seeing the planets. Last year we saw Mars disappear behind the moon in real time and through one of the video cameras, which was quite cool. We also have a quest which is about the star Algol. Now, Algol is an incredibly interesting star. The blinking eye of the Gorgon is the quest down here. And it's what's called an eclipsing binary star. And it's where one star is orbiting the other. And we see this very rapid brightening and dimming of the star Algol. So you can do that. IICSN has a question for us. Got hand up. Yes. Hi. Can you unmute? Anybody else got a question while we're waiting for that?
I do have one more question.
Jenny, yes, carry on, please.
Okay, you said there's the two telescopes, Chile and whatnot. Does
Two
this also
observatories,
give our students access to Kepler or the James Webb Space Telescope that they just launched?
No, unfortunately not. I mean, if you want to access that, you need to go to the NASA website. They don't release any information, any data live. All of the stuff that comes out from either the Hubble telescope or the James Webb telescope is processed over days sometimes before it's released. It's not in the public domain. But this is where this platform is very different and far more personal than that, because you could go off, all of you could go off onto the internet now and you could find 100 different astronomy lesson plans, right? And they might include Hubble Space Image Telescope images. You may even tell your students, hey, listen, go off and get an image from Wikipedia. That's not what Slooh is about. This is about them using the live telescopes and capturing their own personal image of that object. And that particular image that they capture might have a satellite streak going through it. It might have some strange colors over it if there was some light cloud. And it's really teaching them about live astronomy. But more than anything, it's about giving them ownership of that particular data, that particular moment in time when they captured Jupiter and the moon Io transiting across the face of it. So, you can hop over and there's lots of places where you can get all of those other images. Anybody else got any questions?
Hi,
Connie.
Paul. Yeah, this is Connie. I have a quick question for you, Paul, if you have a minute.
Of course.
We have scheduled across the school an hour at the elementary campus and an hour at the secondary campus every day for people to do aviation, aerospace, and they can use your telescopes and run classes and everything through it. Mine is more of a technical question. Is there a number limit for the amount of people that can access without bogging the system down?
No, there isn't. Not at all. And that's either from your site or globally.
Okay.
We have thousands of people logging in at the same time to watch the live telescope views every night. There is also no limit, Dr. Mellin, on how many missions your students can set up, how many images that they can capture, either on a nightly basis or a weekly basis or even over the year. The only limit that your students have is they can only set up one mission at a time. But as soon as that mission runs, they can set up another mission. They can also do something which is worthwhile me showing you this. I'm going to go to mission setup again, and I'm going to go to the by telescope page here. And this shows us tonight's schedule. Let's say let's see the schedule for the Canary 2 telescope. Here we can see there's 3 little buttons. Now your students can come in here, they can click those 3 buttons and they can say, join this mission. Your students can join 5 missions from other people. That means that it's the equivalent of them having control of that telescope at that time, because all of the images from that mission are now going to be made available to me when I go into my dashboard in the morning. So that's another really important feature that your students can use. And a lot of schools are using that feature to have their class collaborating. So one student is setting up a mission for one type of nebula, another is setting up scheduling a mission for another type, but then they join each other's missions as well. And that can prove very beneficial. Frank, you had sorry, Connie, did you have another follow-up?
No, I just think this is very exciting, especially as the teachers are getting the students interested in astronomy, in aerospace, in all of the pictures and the visions and the information. I think that this is a great starting point for our aerospace lessons for the students and the teachers this year. And so I thank you for this. This has been wonderful.
Well, we do have, Dr. Fainin, some new quests coming up, which are specifically driven to the new space industries. So keep an eye open for those. Our director of curriculum is working on those at the moment. So, Frank, you had a question.
Yes, thank you for taking my question. This is very interesting. So I'm just running through my head here. If I wanted to have my students go and search out Alpha Centauri, for instance, and they could all go into your system and look up Alpha Centauri and go to that, and then we could like have a class discussion about Alpha Centauri.
Yes, you can. So if I can get some spelling right, Alpha. Actually, I think I might find this with Proxima better. So not all stars are in here, but if I go to Proxima Centauri, which is Alpha Centauri C, you can go in here. You can see previous images of it. You can read about it in here, but then they can go in, they can set up their own missions. And if you elect to allow your class to share observations with the rest of the community, their observations will appear here as well. So
very good. Thank you.
This is actually interesting. This is what somebody's done with their image of Alpha Centauri, and they're actually marking. So Alpha Centauri is it has a lot of stars making up the system. It's a multiple star system, and he's actually taken one image showing the context of it, but he's also showing each component in comparison to our sun, and all of this background image here were taken with the Slooh telescope. So he's showing the orbits of these other stars and how far around they are and how it's changing over a number of years. So, any other questions, folks? Otherwise, I think I need to. I'll stay as long as you would like me to stay, or however long you've got time for. I can talk the hind legs off a donkey, I've been told.
One of the things that we've been talking about as we're watching the presentations and the making of the posters is how exciting it's going to be to start a wall of their posters where they can explain to their parents what they learned, explain to other people, and show samples of their work. And it looks like museum quality work when the printing is done. And that is exciting everybody in the office with me today.
Yeah, I mean, these really are, I mean, they're wonderful. I mean, this particular one here, the Great Orion Nebula, so this is our Hunting the Hunter quest, but you know, the infographic itself is down here. Where is it in the sky? And it normally includes the things that they've learned during the quest, so the key learning points. So why does it glow red? We've got a little diagram there of the excited electrons and stuff like that. But you also notice here we've got Tennyson's Merlin and Vivian. This is part of, you know, stretching out beyond STEM, and this is, you know, Tennyson writing. He also wrote a poem which included the Pleiades star cluster as well. We've got facts and figures in here as well. But you're right. I mean, students are so proud of these, and of course they all have very different purposes as well. So this particular one is demonstrating the student has captured 2 images of the sun through the telescope over a period of days, and we can see how the sun is rotating, because we can see this active region here has moved over here. And you can take these exercises as far as you like to go, because different regions, different latitudes of the sun rotate at different rates. So you could have your more advanced students, tracking that and actually doing the calculations for those things as well. So, any other questions, folks? So Victoria did ask, is there a limit to the amount of images that we can have in our class? No, no limits there. And are there any others in there? Right, so universal time, UTC, yeah, is shown there, but you may have noticed when I went over to the schedule page here, oh, wrong one, this one, and by telescope, you'll see that these times here, and also in your email reminder, we've got Pacific and Eastern time shown on the schedule as well. But there's one thing I do recommend, your students get used to, is the use of UTC. And you've only got to think about your time zone in relationship to that, the offset, because it is important. We've got 2 observatories that open at different times, and UTC is used in astronomy so that astronomers around the world can use the same time standard so that they can compare their data using the same timestamps. Any other questions, or shall I let you get off? I know you've got a packed day ahead. Well, I would say, don't let it stop here. This project for you guys is incredibly important to us. And I don't say that to all schools and institutions and districts and stuff that come to us. Dr. Malin, you are inspiring. You've inspired us in our conversations with you over the last 6 or 7 months. And I have to say, all of your educators are rather lucky to have you. But that means we want to pull out all the stops for all of you to make this a success in your schools. So please feel free to email me, paul@slooh.com. You can bypass any support system that we have in place. If you run into any kind of problem, email me, paul@slooh.com, and I'll get back to you as soon as I can.
I want to thank you today, Paul, for the training, for your enthusiasm, for your love of astronomy, because as I'm looking at a lot of my staff members, you've piqued their interest, and I think you're opening up the world for our students for something they'd never see anyplace else. I truly am grateful to you. Thank you.
Well, thank you all very much indeed. So, and good luck for the rest of the day and your PD day. So take care, everybody.
Thank you. Have a great day.
Bye now.